So we have two arrays of numbers, and we want to find for each position how many similar same values exist for both arrays A and B. So example, if they have values 1 and 3 and this 3 and 1, so the count would be 2, and we should return this list of results for each position. Now the solution is just you have to push both into running hash maps or hash sets, hash set A, hash set B, fill them, and you have to keep a running counter and 2++ if before pushing, it has to check if this value like 3 in this previous positions of array B, and the same for this 1 in B in the previous position of array A, and extra case if they both equals values, you do extra counter. Now let's look at the solution. So this solution is O of n time complexity and O of n space complexity. It doesn't require you any other conditions, but we have conditions for this problem, like the size only 50 elements, 50, and that means we can optimize. For example, we don't have to store in hash maps, we can just use bitmasks, like in a long value or I64 in Rust. You can use the bitmask one shell shift left a position I. So this would be operation or bitwise, and then you have to collapse them into bitwise AND operation and count how many bits you have left, because if AND 1 and 1 equals 1 and all other combinations are 0, so that means if you both have both values in an A and B, you have the match. Now the other solution is just super crazy brute force in O of n squared. You just go, and at its position you just intersect these prefixes, and it would be accepted because we have only 50 elements. By the way, bitmask works only because we don't have duplicates, no duplicates, and this is also extra condition. Now let's look at the shortest version of the code for the Kotlin. It is brute force. You use intersect, and for the Rust you have to use bitmask. You can also use scan operator, and it would be a little bit longer. So this one is optimal both in how many characters you have, and this is O of 1 space complexity, or of n space complexity, of n time complexity. That's it for today.